Dear everyone, come back to Java classes. Today we will see operators. Operators are special symbols to perform specific operations using 1, 2 and 3 operands. Means 3 values. Operator works on one value or operand is called unary operator. Maybe size of, plus plus, minus minus, unary minus are called unary operators. Operator works on two operand is called binary. That means works on two values. Maybe for example, plus, minus, we will take A plus B, A minus B. Then it works on two values. Operator works on three operand is called ternary operator. Maybe comma, maybe question mark, conditional operator are called ternary operators. Expression evaluation. How the expression is evaluated in Java. There are two common rules. One is precedence of operators, that is nothing but order of operators. If there are more than one operator in an expression, then it determines which operator is performed first or evaluated first. In expression, if there are more than one operators with different precedence, and even it will follow one more rule, associativity rules. That is, along with precedence, and it will check whether that operator is from left to right or right to left. In Java, there are three operators which are from right to left, and all other operators will take the associativity from left to right. The people who know about BODMAS rule, it is the same concept extended, but there are more number of operators in Java. And as you know, BODMAS rule brackets order of division, multiplication, addition and subtraction. Brackets are taken first, then division, multiplication, addition, subtraction. The same concept is followed here. We can see operators and its precedence in Java. The first operator is postfix, that is plus plus, minus minus from left to right. Then the unary operators, that is unary plus, unary minus, and then not operator, then the negation operators, bitwise operator, and then plus plus, minus minus. These are from right to left. Multiplicative operators, multiplication, division and modulus are from left to right. Additive operator, that is addition and subtraction, from left to right. Shift, left shift, right shift, all from left to right. Then relational operators, less than or equal to, greater than or equal to, all from left to right. Then the equality operators it will take. Double equal to, that is logical equal to or relational equal to, and relational not equal to, left to right. Bitwise operators, that is bitwise and bitwise XOR, that is caret symbol, and then pipe symbol, bitwise OR, and double ampersand, double pipe symbol, those are for logical and logical OR, all from left to right. Then the conditional operator, that is question mark, that is also from right to left. And then last, assignment operator, equal to, plus equal to, minus equal to, then asterisk equal to, then percentage equal to, all are from right to left. Now before moving to other things, we will see one example on operators precedence, how it works. Here we can see one example. Class precedence. Int a, b, c, d, e, f, g, h. We have taken some variables. Now I took one value, a is equal to 4, b is equal to 2, c equal to 3, d equal to 4. Then I took one expression as e is equal to a plus b divided by c minus d in normal way. How we will take that type of method. Then I took one more, f is equal to in parenthesis a plus b, then division symbol, then in parenthesis c minus d. This is second method. The same expression in another form. Then g is equal to a plus b in brackets, then divided by c, then minus d semicolon in another form. H is equal to a plus b with no brackets, then division symbol, then in the brackets c minus d semicolon. Then I have printed everything E, F and GH. So now we will save this program. Then we will run in Java, C, Precedence .java. Okay, now it is compiled. Then we will run by taking Java Precedence. Okay, now you can see the result. E is equal to 0, F is equal to minus 6, G is equal to minus 2, H is equal to 2. All results are different. Even though the expression is same, but it is used in different way, so the results are different. That means in Java, precedence operator and precedence of operator and associativity is important. That we can see by these examples. E is equal to a plus b divided by c minus d. You can solve it and you can find out. In this expression, it will take b divided by c first, because division is having higher priority compared to plus. So b divided by c, that is 2 divided by 3, that is fractional. So it will take it as 0. A minus d, a is 4 and d is 4. So 4 minus 4, the result is 0. But in the second expression you can see, it will take a plus b first, since the brackets are having higher priority, and then it will go for c minus d, then division. And in the third expression, it will take a plus b first, then divided by c, then with the result it will take minus d. And in the last, h is equal to a plus b divided by c minus d. So c minus d it will take first, then b divided by c minus d result, then it will take plus a. Next concept is arithmetic operators. So we can see there are so many arithmetic operators like plus, minus, multiplication, division, modulus, percentage, plus, and then assignment operators. Plus equal to, minus equal to, multiplication equal to, then division equal to, then modulus equal to, and then minus, decrement. Okay, there are so many operators. And you can see in Java, when we are using compound assignment operators, these things, compound assignment operators, you will get the advantage of implicit typecasting compared to normal assignment operator. That means instead of taking a is equal to a plus b, we can take a plus equal to b. And this plus equal to works in different way compared to a is equal to a plus b in Java. That we will see with example. What is the difference between that plus equal to and normal a is equal to a plus b. Okay, I'll take one class compound, public class compound, then curly public static void main string args double b is equal to 2.5 int a semicolon. Now I will use a is equal to, here I will take some value, integer value, a is equal to 1. A is equal to a plus b. This is one method. In another way, a plus equal to b. Again one more method, b plus equal to a. We will print system dot out dot println a is equal to plus a semicolon. I'll copy the same thing, Control C and then Control V, and here I'll take again a is equal to, and here I'll take b is equal to b. Now end of main, end of class. So we will save this program as file save as compound dot java, and here take all files, then save. Now run this one. So java c compound dot java. Okay, now we can see there is error for this statement, incompatible type, but for other things there are no errors, only for the sixth line, that is a is equal to a plus b, there is an error. That means for these things it will use implicit typecasting, so there is no error, but for this one there is error. So just we will comment this line, and once again we will save this and we will run. Once again we will compile. Okay, now it is compiled with no errors. Now just we will run java compound. Now a is equal to 1, so directly it is displaying a value, and then a is equal to 3 because of this statement, a plus equal to b. That means a is 1, 1 plus 2, since b is double but it is changed as integer, so a is equal to 3. But in this case b plus equal to, that is b is equal to b plus a, it took 2.5, okay, plus the previous value of a, that is 3, so 5.5. That means the implicit typecasting is available in this plus equal to, that is not there in the equal to and plus. That advantage we will get when we take plus equal to operator. And another advantage is here there are two operators, that means the compiler works on plus and then equal to, but here it will be treated as one operator, so this is faster. So when we are doing some programming, it's better to go for this type of operation instead of this type of operation. Remember this concept. Next we will see one example on arithmetic operators. You can see on screen class operators, that is public static void main string args. Then I took some variables, and a equal to 20, b equal to 30, c equal to 40, d equal to 50 is equal to 60. Now we made one operation, f is equal to a plus b. This is just to demo on arithmetic operator. G is equal to a minus b, h is equal to a into b, then I is equal to a slash b, j is equal to a mod b, then D plus equal to A, that is D equal to D plus A, and then E is equal to E mod B, then K is equal to A plus B plus C. That means even we can take 2, 3 operators as well as 2, 3 operands. Then I printed this one. So just we will save this program. Then we will compile. So Java C operators dot Java. Okay, now Java operators. Okay, now you can see the result. By that you can see full thing on screen. Now the next is comparison operators. And this comparison operator, some people will call it as a logical operator, but we will take it as a comparison. As you know, in C, C++, commonly you referred it as comparison operators. Less than or equal to, greater than or equal to, not equal to are comparison operators. We will see one example on this comparison operators. Class, we'll take public class. Even the class works, but in some situation we need public. Public class comparison. Then public static void main string args. Then we will take some values. Int a is equal to 4, comma, semicolon. Int b is equal to 8, semicolon. Then we will take int c, semicolon. Now c is equal to a greater than b. System dot out dot println c is equal to plus c. End of main, end of class. Even you can take like other things like int c comma d, two variables. D is equal to a greater than b. And that also you can print. D is equal to d. Now save. Comparison dot Java. Then take all files, otherwise it will add .txt. Now Java C dot Java. Now it is with error. Incompatible types. Boolean cannot be converted to integer. Okay. Now we will take this one as Boolean. Okay, now it is compiled. So you can see the difference. When we take int, it is not compiled since the result is true and false. And integer variable will not take true and false in Java. In Java, there is separate data type called Boolean. Now we will run this one. Java comparison. Now C is equal to false, D is equal to false. We have taken both the things as same. So I will take A less than B here. Once again I will save, once again I will compile, and then when again we will run. Yeah. So in Java there is special data type called Boolean. By that we can take Boolean type of result. The next concept is bitwise operators. In Java there are many number of bitwise operators like bitwise unary not, bitwise and, bitwise or, bitwise exclusive or, that is caret symbol, and then shift right, zero fill, shift left, and then bitwise and assignment, bitwise or assignment, bitwise exclusive or assignment, shift right assignment, shift right zero fill assignment, shift left assignment. The first we will see bitwise not. The bitwise not, it is to reverse a bit. It is also called as bitwise complement. The unary not operator, and it uses tilde symbol. It inverts all of the bits of its operand. It inverts all of the bits of its operand. If I take tilde 101111, then it becomes 1 is converted to 0, 0 is converted to 1, and then all 1 are converted to zeros. So in Java, it works in little bit different way. If you take tilde 3, then it displays the result as -4. If you take anything, like if you take tilde 4, it displays the result as -5. If you take tilde 10, it displays the result as -11. So here, how it works, why it displays the result in that way, that we will see. So bit 3 is equal to 0011. If you take x as 3, then tilde x, that is not x, negation x, equal to 1100. In Java, the first value 1 is taken as minus symbol, that is to represent the negative value. That means if the 1 comes in the result, then it will take it as a negative. If the 0 comes, it will take it as a positive. The tilde is the bitwise not. So when the first value in the bit string is 1, it takes as negative. So the result is 100 means 4, and this one is minus. So -4. This we will see with one example. Public class not public static void main string args and take int x is equal to 3, same value, and then system dot out dot println negation result equal to tilde x plus tilde x semicolon. So not dot java files. Yes. Then Java C not.java. Okay, now Java not. So result is, that is tilde x is -4. That means when we take 3, it displays -4. We will change. So we will take 15. Control S, and again we'll come back, we'll compile. Then we will run. So -16. Okay, you can find out the thing. Whichever number you are taking, the negation of that thing in Java is one number more with minus. Next is bitwise OR operator. It is also called as bitwise disjunction. The OR operator symbol is pipeline symbol. So in the screen you can see in keyboard where it is. And then it combines bits such that if either of the bits in the operands is 1, then the resultant bit is 1. So you can see truth table. So 0 0 1 0 1 0 1 0, that is 42, or 0 0 0 0 1 1 1 1, that is 15. And one thing you have to remember, if the 8 bits you are taking, you have to take the next number as 8 bits. 0 or 1 is 1, 1 or 1 is 1, 0 or 1 is 1. So in this way the result is 47. The same way, one more thing, bitwise AND. That is called as bitwise conjunction. And the operator for that one is ampersand. It produces one bit if both operands are 1. 0 is produced in other cases. Like 0 0 1 0 1 0 1 0, 42, and then AND 15, the result is 10. And the AND truth table is given here. Okay, this is just like your Boolean AND. The same way it works, bitwise AND. Then bitwise XOR. The XOR operator, that is caret symbol, in keyboard you can see where it is, combines bits such that if any one operand is 1, it gives the result as 1, otherwise it returns 0. Again we took the same numbers, 42, 15, so the result is 37. And here you can see one thing, when 0 and 1 is there, then there is result. Anywhere 1 and 0, 0 and 1 is there, there will be result, otherwise no result. And that is the XOR truth table. Now we will see one example. So we took one class OR and X, public static void main string args, A is equal to 42, B is equal to 15, what the values we have taken. Then int C is equal to A or B, int D is equal to A and B, that is bitwise AND. Then exclusive OR, E is equal to E, A exclusive OR B. Then, so we'll save this one. I'll save as OR and ex.java. So take this one as all files. Save. Now compile Java C OR and ex.java. Now Java OR and X could not find, since we have changed while compiling. Okay, now we will run. Yeah, so you can see these are the errors, it will come sometime. So Java C or at EX, X we took capital, but the class name is X with lowercase. So you have to take it in the same way in the manual methods. Now our result, C is equal to 47, D is equal to 10, E is equal to 37. The next bitwise operator is left shift. When we use left shift in Java, most significant bit MSB is lost and a 0 bit is inserted on the other end. The left shift operator is double less than. You can see 0, 0, 1, 0. We have shifted 1, left shift 1, then the result is 0, 1, 0, 0. So bits are shifted towards left one time. Again we took 0, 0, 1, 0, left shift 2, then 1 is shifted to 2 places left. Now the result is 4 and here the result is 8. So we have taken the value as 4 and the result is 8. A single left shift multiplies a binary number by 2. That means if you take 2 left shift by 1, then it will be 4. 2 raised to 2. 2 raised to 3 and it may be 8. So again it continues. Again if you take 2 left shift 3, then the result may be 16. That may be 2 raised to 4. So in this way it continues. A single left shift multiplies a binary number by 2. Then the right shift. When you shift right, the LSB, least significant bit, is lost and a 0 bit is inserted on the other end. The right shift operator is double greater than. Here you can see we took 0, 0, 1, 0, 0, 0, 1, 1, then the left shift 2, then 2 bits are lost. Before right shift the value is 35 and after right shift value is 8. 0, 0, 0, 0, 1, 0, 0, 0. So we will see the example for this one. So I am showing example for everything, by that it will not be a boring theory. And in this one I can take like star.java, it will show all the Java program what I have made previously. So whether there is left, right. Okay, so we took one program here, class left right, publish static void main string args, int a equal to 2, b equal to 35, c is equal to a left shift 1, d is equal to a left shift 2, 1. Then the system.out.println command. We will save this one. I'll save as left right.java. All files. Now we will compile Java C left right.java. Now we will run Java left right. So you can see the result. So in the beginning C is equal to A is 2 and it is left shifted by 1, the result is 4, that is 2 raised to 2, and D is equal to A left shifted by 2, that is nothing but 2 raised to 3, that is 2 multiplied 3 times. E is equal to B left shifted by 2, that is 35, right shifted by 2, so the result is some bits are lost, the result is 8 again. f is equal to a is 2, again left shifted by 1, so the result is same 4. Thank you friends. We'll conclude here. Share with your friends and like the video.